All right. Taking me a little longer than I originally planned to record this video, so apologies if you've been waiting for it. That's mostly because my client-side injections video ended up being about 5 hours long, so it took a little longer than I expected to record it, get it edited, and everything. But anyway, if you want to learn more about client-side injections, bug bounty hunting on real-world applications for client-side injections, right? So identifying all the different compensating controls, how to bypass the individual compensating controls instead of just throwing payloads of polyglots and things at it and hoping something is going to pop an alert, then I definitely recommend you go take a look at that video. But anyway, today we're going to do our part 3 for indirect object references and access control violations. So just as a quick refresher, quick reminder, indirect object references, IDORs. We're looking for somewhere in the application where there's a mechanism that is using some type of unique identifier. So that could be just a sequence number 1, 2, 3, 4, 5, etc. Typically in modern applications, it's going to be like an object ID or a GUID or something that's going to be a little bit more complex. But ultimately what the application does is it's taking that unique identifier and it is querying a larger data set from the database, and that larger data set should contain some type of sensitive data. That is the attack vector that we're looking for in the application to find an indirect object reference. Once we find that, we are going to try and replace that unique identifier with another unique identifier for an object or a data set that we should not have access to. And then if we're still able to access that data, and we're at that point getting sensitive data that we should not have access to, we have found an indirect object reference and we can submit that as a valid vulnerability. If you saw part 2 of this series, you know that's in direct contrast to access control violations. In an access control violation, we're not trying to get access to data, we're trying to get access to mechanisms. So something that allows me to read, write, update, or delete that data that's going to be within the database. For IDORs, the way that we do that testing, remember, is we have 2 completely separate accounts and we're trying to communicate between those 2 accounts. But they're typically going to be the same role. They don't have to be, but you can do that testing on the same role and it's typically easier. With access control violations, we are going to get into an application that has multiple different layers of access controls of different roles, right? So we could have an admin, we could have a limited user, a super user, multiple different levels there. And those roles are able to access and execute a specific set of mechanisms within the application. So our goal for access control violations, if we remember, is to try and access mechanisms that we shouldn't have access to as that role. So if only an admin within an application can invite new users to the application, if you can find a way as a typical user to send out a valid invite, then you have found an access control violation. Then we can try to build impact on that, right? If we found that, that's not bad. But what if when we send this, we can also control what the role of that user is. So not only can we create a new user, we can create ourselves as a new user and we can escalate our privileges. Like we were originally a user, but now we can send a new invite for an admin user. Even though we're only a user, we can step that up. That shows how we can kind of build impact on that. So IDORs, accessing data, access controls, accessing mechanisms. But with that being said, in this video, we're going to put everything together. We're going to build this into a unified methodology. And ultimately what we're doing is we're going to get into the application. We're going to start to define the boundaries within the application. So what should a user be able to do and not be able to do? And those IDORs and those access control violations are how we're going to test those boundaries. Sorry, I can't talk today. It's been a long week. So that's the goal today. We're not going to spend a lot of time talking up front because honestly, we've gone through a lot of the theory here. So we can jump in pretty quickly and go ahead and see what that methodology looks like when we put them both together, right? When we're not just testing for IDORs, not just testing for access controls, but see how the 2 play together to help us identify the boundaries within the application that we can test to see if we can manipulate those boundaries or possibly break them. We are going to be introducing 2 new technology concepts in here in this video. The first is, and I mentioned this at the end of the last one, instead of doing our testing on a web application, well, actually, we are going to do some on the web application that's access to the browser, but we are also going to do our testing on a desktop application today. And maybe you've seen some other videos about this or anything, but this is my favorite technique for finding API endpoints that other researchers have not tested. A desktop application, and this is really true for a mobile application as well, most desktop applications are connecting using HTTP requests to some type of a web server or database to communicate data back and forth. That's not the case for every desktop application or mobile application, but most modern ones today, that's certainly the case. I know a lot of researchers, especially when they're starting out, they can think it can be very difficult to do testing on desktop applications. They think you have to decompile it. They don't really know how to approach that. But I'm going to show a very simple way where we can actually route all of those HTTP requests that are coming from that desktop application to the target's web server. We can route all those calls through the BERT proxy, through our operating system, and then just by the nature of using the desktop app, we're going to be able to capture all of those requests, and we'll be able to do testing on them just like any other API endpoint, right? But that's hopefully going to allow us to find endpoints that have not been tested that much. What this does is it adds an additional level of complexity, and that's what we're always looking for as bug bounty researchers or attackers, right? We're looking for tech debt, we're looking for complexity, because where there's more complexity, there's areas for things to fall through the cracks, there could be oversights, and that's what we want to kind of dig into as attackers and see if we can find the bugs in there. So with a desktop application, there's really only two options that the developers have when they're going to build a desktop application. And if they've got to communicate data from a database that is held within their cloud, and so they're doing that with HTTP requests, right? There's only two options. Either they've got a web application that already exists, and they're going to use the same endpoints that web application uses to manage the desktop. Or at least as many as they can, right? Because there's got to be some additional endpoints that are not used there, typically with like initializing the desktop application and things like that. But that is a one option that they have, right? You can go in, you can leverage the existing endpoints, and at that point, if the desktop application has any variability with the web application, then they have to start kind of doing some little workarounds and some tricky stuff with the code here. And that's where that additional complexity, that additional little kind of hacky tricks that they can do to say, well, this endpoint was originally designed to do this, but let's maybe say if it's coming from the desktop, we give it a special user agent or some type of way to identify it as coming from the desktop, then it'll have different functionality or things like that, right? That allows us to identify that complexity and hopefully find bugs within that, the differences in functionality between the two types of applications. The other alternative is that they're going to build an entirely new API specifically for that desktop application. Now that means that it's probably been a little more thoroughly tested and everything. There's going to be less complexity there, but it also means that the researchers that are testing this web application are not testing any of the endpoints that are used for the desktop application. And I can tell you there is a very small number of researchers that are currently doing this, although who knows, maybe it'll change after this video. But I mean, when I started focusing on desktop application APIs instead of APIs that I just enumerated through applications in the browser, I saw a significant increase in the amount of bugs that I was finding just because it was very clear that a lot of these had not been tested. So whether this application is kind of using this hacky method to leverage existing endpoints, or if they've built an entirely new API that we're going to be able to communicate with, we're still going to be able to take advantage of either one of those scenarios. It's just going to be a different methodology, right? Are we looking for complexity and digging in, or are we hoping that these API endpoints just haven't been tested that much, and we're going to do a much more thorough, comprehensive type of test with that? The last section that I want to go through here is we're also going to run into a WebSocket when we are going through our testing here. So I wanted to show how indirect object references and access control violations can also arise within a WebSocket. And just a very brief overview if you're not familiar with WebSockets. So HTTP requests, typical traffic when you're communicating with a web application, it is not stateful. It's stateless. And what I mean by that is there is no connection that's maintained between your client, your browser, and the web application in the cloud. Every individual HTTP request is read in isolation with that application to say, okay, who is this coming from, et cetera, et cetera. That's why you have to send your API key for every request and everything, you know, just as one example, right? But it's HTTP, HTTPS are not stateful protocols. The WebSockets were designed to solve that problem, right? Or at least when that becomes a problem, when you need to establish a stateful connection, you would use WebSockets for that. And so what that looks like is there's an initial process of establishing this connection through the WebSocket and saying, okay, this is who I am, this is the data that I'm accessing, these are the, all these different things. And that may be constantly confirmed as the WebSocket is communicating back and forth, but ultimately there's an initial instantiation to where you're getting in and telling that WebSocket connection what data you're accessing, who you are, etc. So for IDORs and access controls, that changes the way we test. We're not going to look at every individual request that we're sending and every individual mechanism. Instead, we're going to look at how, when that WebSocket is initially connected, what information are we telling the WebSocket? Can we trick it to think that we are a different user using a unique identifier of another user or something, or a different role or anything else potentially? And WebSockets are not typically as thoroughly tested compared to regular endpoints. I think it's just a little bit of an unfamiliar technology to some people, especially beginners. But right, as we always talk about, the less testing there is, the more opportunities for you to find your first bug. And I promise it may seem intimidating at first, but they're really not that. Establish the connection, tell them who you are, and then after that, the WebSocket requests are typically just data that's going back and forth. A lot of times it's just JSON data. So we'll look at how the WebSocket is initially connected, how we are proving who we are, and what data we're going to manipulate, etc. But then we're also going to look at those individual requests that are going back and forth from the client and the server. Once it's connected, what are they doing? Are they also sending any unique identifiers that we can possibly manipulate? Is there something within each of those requests that continues to declare our role that we can possibly manipulate as well, or point it to a different data set? So that's the plan. We're going to be looking at Figma, which Figma is a very cool application that's designed for standardizing your client side code in your application, right? So different design choices, things like that. And it's got an online platform that allows us to collaborate while we're doing that, right? So it's a really cool app with a lot of complexity in it, right? It's a collaboration tool. So we can spin up our desktop application, and we are going to log into our server there, and that desktop application is going to establish a connection. And at that point, we can manipulate all of these different design utilities and the teams and the roles and everything within this application through the desktop application, and we'll be capturing those in the burp proxy and manipulating them and testing on them. So let's go ahead and get the screens flipped here, and we'll get started. So this time we're going to have a little bit of a different setup that we need to do before we can actually get everything going. And you can see here that I'm on my Windows machine. I'm not actually going into a virtual machine or anything else. We're going to do everything on our Windows operating system here. All you're going to need is Windows. You're going to need a web browser, so I'm going to use Firefox, and then you're going to need Burp Suite installed on your Windows machine here. That's it. It's really as simple as that. So the first thing that we need to do is we need to set up our proxy on our Windows operating system so that any HTTP requests that are leaving this machine, leaving this operating system, are going to be routed through Burp's proxy before they go out. So we need to start by getting Burp Suite set up. I'm going to come over here and open this up. Should take just a second to pop up here. There we go. Okay, so I'll do a new project. I will call this one Demo like I usually do. And we'll just use the burp defaults. That's totally fine. So once this comes up, it keeps wanting to go to a screen that I'm not sharing, so that's super great. Our burp proxy here, we can turn intercept off. Our burp proxy, once we configure our Windows, is going to have all the traffic coming through it from every single application and browser, and even the Windows operating system is constantly sending traffic back and forth from the Windows web servers. It's a ton of traffic that's coming through here. It's not going to make sense for us to be able to read through that without filtering it in some way. So I mentioned earlier that we're going to be targeting the Figma application. So what I typically do when I start this, because we don't know what the domains are going to be, so we have to just kind of guess at some of the domains that we want to capture once we start opening up our desktop application or once we do the installer and everything. So I'm going to come to the proxy settings, come to the scope, and I'm just going to add a simple regex that's Figma. And that at least tells me, and I know their root domain is figma.com. We'll see that in a bit when we get to the HackerOne thing. So I'm just kind of guessing. And that's what I do whenever when I go through the scope, I look at what their domains are, I think about the name, I kind of anticipate what is the simplest regex string that I can use here to catch as much of the traffic coming from the desktop application that I know is in scope without hopefully not getting a bunch of extra noise or anything is coming through. So Figma's probably a pretty good guess there. So that's all we need to do for that. Let's go ahead and come back here. Now our intercept is on. You can see there's no traffic coming through now. Let's go ahead and get our web browser brought up here. And we can just do figma.com. Okay, and now if we come back, we'll see. Now the browser is not actually sending everything through the proxy yet, because we haven't done anything to modify our operating system. So just to confirm that everything is working so far, I'm going to come up here. We're going to route everything through Burp with this extension. I will click on this again, and we should see we do some traffic to figma.com that's coming through there. Perfect. Okay, so we now have the ability to log in to test the Figma application through our web browser, something that we almost always have there. So before we install the desktop application, I'm going to go ahead and set the proxy for Windows. And the reason for that is the installation itself can actually involve some HTTP requests that we can do some testing on as well. It's a step that I see some people miss even while they're using this technique. So make sure you've got your proxy set before you're installing the desktop application, right? So what we do to do that, we can come and click on the search bar down here. And then we're just going to type in, you can actually see it already on my history, we're going to type in proxy settings. Okay, system settings, proxy settings. And we can click on that. It's going to open up this nice little box here. And we're going to come down to manual proxy setup right here. Okay, now you hit setup and it's going to open it up. This will be off. These will be empty on yours. I've come in and previously written these in. These will be empty. But all you do is click on, and then whatever the IP address and port of your Burp Suite proxy is what you're going to put here. Now the default is 127.0.0.1 and port 8080. So if you're running on the default settings, you would just make your Windows proxy settings look exactly like mine. If you have any custom settings, or if you're just not sure what that proxy is, you can open up the settings, go to Tools Proxy, and you can see here in the proxy listers, you can see exactly what that is, right? So 127.0.0.1, the colon is the delimiter, and the port is 180 there. So that's it. We're going to go ahead and hit save. This will turn that on. And now any requests that go through our machine itself that are going to, that have a domain that contains the word Figma, we will be capturing those within our Burp Suite proxy, and we can do testing on it. So now that we have that set up, we can go ahead and close out of this, close out of Burp Suite there, and we can now go ahead and download the installer for the Figma desktop application. So let's open this here, and probably the easiest way, I don't actually know how to get to it from the main page here, but let's just do download. If I remember correctly, they do have I think they have a download link as well on the main page, but this is perfect. Okay, desktop application, download app for Windows. If you're doing your testing on Mac OS, hopefully you know to click the Mac OS. Should be pretty simple here. Go ahead and let that load for a minute. Maybe a little more than a minute, huh? You can see here now we're already starting to get an idea of what those subdomains are. So all of these are coming through the web browser. We're picking all these up and starting to enumerate our sitemap. This is, oh, there we go. Okay, so it just took a little longer, probably because of the routing. That's the reason it was taking a little longer. It's totally fine. So let's do this. Before we actually run the installer, let's come back over here to Burp Suite, and I'm going to turn the intercept on because I want to see what this installation process actually looks like. So let's do that. Come back over here, and then we'll come up to our downloads, and we're going to go ahead and run the exe. And now we will kind of just wait and see what happens, right? Because we're spinning up. Ah, there we go. There's our first one. So the desktop application has opened over here, and it initially is sending a request to this release.json, right? Okay, so this Figma ID, we've got a version number, we've got an architecture, an operating system version, everything else. So we're already establishing a connection with the web server to give that web server information about the granularity of our system. And then from that, it's going to make some determinations. It's got some logic on that. This is not logic that the web application needs to go through when you're accessing through the browser. These are additional steps. So this is already a great opportunity for us to potentially fuzz for some injection points if we want to. We can also take a look and see, I wonder if maybe we can get access to an older version, and that will cause some type of discrepancy. You know, what happens if we can find vulnerabilities in older versions of the desktop application? Will they allow me to, you know, maybe set this desktop application up as that version? I have no idea, you know, but these are all options to fuzz that a lot of researchers are never going to see because they're just going straight to the web application version of it. So let's forward that there. We're getting some local files here. It looks like pulling some data, pulling a download file as well, right? So some other endpoints that we can fuzz. Although that's interesting. Yes, we're starting to get into some, oh, this is Windows, never mind. Why is Windows getting caught in here? I'm not sure why those are getting caught with Figma. I must have something in that I missed, or maybe that's the user agent possibly. I don't know. And now we're going to a login page. I would imagine that if you were to come and copy this URL and bring it back over to our browser, will this redirect us? Oh, I'm still intercepted, aren't I? Oh, shoot. Okay. We'll check that in a second. Or actually, why don't I just do this? I think if I drop this off, we should be able to do that there. No, I can't because Windows is still routing everything through the proxy. So that's a neat thing there. Cool. Okay, we'll span through a little bit, but that does look like it's accessing just the typical login page. Oh, and there were our requests. So yeah, we can go ahead and turn this off at this point, and it will bring up the login page. Okay, so we can expect that potentially this is going to be loaded in the desktop application as well, or what's probably more likely is they're going to load it up as something on the back end to where you can redirect to the browser to log in here. So yeah, so you can create a user, or so that login endpoint there looks like it was basically done to populate this. So let's click on the login. Now it's opening in a browser up here, and I'm going to get rid of that just for the sake of the video. We'll replace this with this URL here. I'll tell you what, hold on, let's do this because I want to kind of compare those two. So if you look here, when you typically log in, let's go back to just refresh it. So when you typically log in, we're just going to HTTPS, Figma, login. We got a couple GET parameters there. But when we're logging in from our desktop client here, now all of a sudden, we have this additional app auth ID value. So here's our first opportunity for an indirect object reference. Would it be possible for us, if we were to steal another application ID value, does that give us access to some data we shouldn't have access to? Because this ID is probably pretty trivial to get either through HTTP requests, or I mean, even more likely, if something's stored in the file system, it can be, you know, any type of spyware, malware, anything, we'll pull that right off. So local file stored on Windows, and this ID is most likely, it's either got to be coming from the web server and HTTP request, or it's got to be stored locally on the file system. Somewhere this ID is being pulled, which means we can potentially get access to that. So already we're starting to see some discrepancy, some complexity between using the desktop application to using a web browser to access this data. And we're also starting to get an idea of how the developers implemented this. Remember in the beginning I said, if we really only have two options. You can either use existing endpoints and you can just adapt them to the desktop application. And that's where you get kind of those, you get the complexity, you hopefully get some kind of hacky, you know, throwing together Frankenstein type stuff that we can dig into and cause some unexpected behavior. Or you're going to have a bunch of brand new endpoints that hopefully haven't been tested that much. It looks like we've got the hacky solution, at least for this login page. So I'm starting to lean more in that direction, but we won't know until we get logged in here. So now we need to go ahead and register for our accounts, right? But I'm going to get my notes pulled up first so that as we register, we can document, hey, here's the different accounts, here's the emails, passwords, all that type of stuff, so we can keep it straight. So just real quick, we'll right click and do a new window here in VS Code. We'll come down here and let's do open a folder, create a new folder, and we'll just call this demo right there. And that'll be fine. So we'll call this IDORS notes, I guess. IDORS AC notes. You know, anything that you want to call it. MD right there. Go ahead and get this off. IDORS and access controls. Big. Okay, perfect. So let's go ahead and register for our accounts, right? So we can create an account here. We'll click on that. And it looks like we can either use Google, which remember is OAuth. That's different than single sign-on down here. It's another video series I'm going to do in a little bit. But we'll go ahead and use our HackerOne here. So the arson at wearehackerone.com. And then we're going to do our plus notation again. So I'm going to do plus, and we will do demo user 1. And I'll copy this. So when we create our second one, we can do demo user 2. Okay, and we'll do the typical throwaway password here. I think they're okay with that. Yep, looks like they are. Okay, and their registration system right here, very easy. You go in, just put an email. So this is using the HackerOne email forwarding. It's going to send this to our Gmail, or send it to HackerOne and then forward it to our email account there. So we will have to copy that and bring it back down. So let's go ahead and grab this. And I do have the new account. So just so you can see, bring this down here. Very simple email, right? So I'm just going to right click on this. I will copy the link address. We can get rid of that. And when we come back down, this should allow us to go ahead and verify that that account exists. All right, perfect. And now we get to do this. So I'm just going to call demo user 1, right? We'll have 1 and 2. And then we should be able to just click through everything else here, right? So what kind of work do you do? We'll just do other, sure, at a company, yep, nobody, whatever, that's all fine. We have the ability to go ahead and invite some other emails. I don't see any options for roles right now. So I don't know exactly how this works. I don't know if there is granularity in the roles or not. So we'll have to dig in and find out. But I'm just gonna skip this for right now. And once we get into the application, we can go in and actually start inviting some other people to that instance of the application, right? We want to go through and create another account, but right now we're creating our accounts for IDORS. So we want them to be completely separate accounts so we can test the boundaries between those two separate instances. And then once we get into the application, we can test the boundaries within it as well. All right, so, okay, a bunch of other values. These are all going to be probably added onto the user object. Obviously, we're going to pick starter there because I don't want to spend any money. And we'll just go ahead and pick this one for the first one. I'll probably do the other one for the next account. So now we've got our instance of the application here. And it's actually, if we open this up, so it's dropped us into one of the collaboration boards automatically. It's created a default one here, right? We can kind of drag it over and I think Control plus. Yeah, we'll get this a little bit bigger, but so this will go ahead and give us an idea of what the application is, what it's designed to do already, right? So here you can see a basic Figma board that's created, right? It's almost like a PowerPoint slide or something that's laid across this open workspace. But what we can do now is we can invite other individuals that would work on the UX or UI team. I probably should have mentioned this too. So that's user experience and user interface, right? So basically these design teams, they work together to basically lay out what a web application is going to look like. So when a new feature comes out, the software engineers will work with the design team to say, okay, the software engineers going to say, here's how it's going to work. Here's what we need to do as far as a technical standpoint, what we're trying to build. And then the design team will come say, okay, well, here's what it's going to look like. You know, Here's what the main page is going to be. Here's all these different, when you go and purchase something, right? So this would be a new application or a new feature within an application. So again, this is the data that we want to target here. If we can get access to any of these Figma boards, any of these, well, they're basically pictures, right? But these designs that will show new features that are coming out within the application, that is how we can demonstrate impact within this application. Again, Figma is one that we actually use at Flowcast. And so our design team is constantly working with this tool together, to collaborating, remotely to build out the designs for the new features that are coming in our tool. If that were to get, leaked for whatever reason, then our competitors could go and see what our new features are going to be, right? It's not a good situation for us. So that's what Figma is trying to prevent. This is the data that we're trying to secure. Now, obviously not these canned examples, but the ones that other companies are using there. So as a bug bounty researcher, that's the data that we want to target. Any way that we can get in and get these sensitive information within these Figma boards, if we can get access to another account to get that, that's what we want to test. So for an indirect object reference, I would be focusing on accessing any of these designs that either my individual user doesn't have permission to access within this instance we just created, right? So if there's multiple different teams, individual team members are going to have access to certain boards. So can we get access to others? That's not as impactful, but what we really want to do as attackers, where we can really show impact here with this application, is if we can get access to these Figma boards or any of these designs for a completely separate instance of the application. Right, so let's say, right, if I just come and create this free instance here, or anybody else does, but then they could get access to our design boards for my day job for Flowcast, that's what we do not want to happen as a customer of Figma. So that's what Figma is trying to prevent. So let's get out of this board itself. Like I said, when you create the new account, here we can just go back to files. Yeah, so when you create the new account, the first thing they're going to do, as you saw, is drop you into one of these workspaces, right, or projects, whatever you want to call it here. So if it's a design file or a FigJam board, I guess is what they're calling as well. So two different types of workspaces, but it drops you right into one that you've created. So what we're looking at now, this is the actual management user interface or management platform for your instance of the Figma application. Right, so you can see here's our actual user. If we come down to settings here, right, the name, email, which this is really our username, and then just some of the generic other values, right, like job title was one of the ones we had to select. Looks like we've got a bit more information here for things that we can do for this. So this is all most likely going to be our user object, which is something that we can try to get access to. We want to get access to other user objects to potentially exfiltrate data. So that's going to be one example of somewhere we can do an IDOR testing for. And now just looking at this, I don't see any other way to invite anyone to this larger instance of the application. So I almost want to say that when you sign up for an account, you get your own private instance of the Figma application. Because if we come up here, right, this is the highest level, right, demo user 1 is logged in, settings, but there's no way to invite another user into this platform itself. This really looks like more of your own personal platform to manage everything that you're doing across multiple different teams, right? You've got the ones that you've recently viewed, you've got different shared files, shared projects. So this is demo user 1's instance of the application that allows them to begin interacting with these multiple different teams that are out there across the Figma, universe, whatever you want to call it, right? Down here we have our actual team. So it looks like when you create an account, you also automatically have a team created. Okay, so, and let's actually come over here because I want to get an idea of this. Okay, so we've created an account with this user. So we have this larger user account that encompasses what we are accessing now. Now, under that, we have a team. Let's just go teams, right? Because it looks like we can do multiple ones, right? We can create multiple different teams. Let's just try demo user 1, team 2, I guess. I don't know. We can create that. We'll skip inviting anyone because once again, we just want to see how this works. We'll do a starter. Yeah, okay. And now we have demo user team 2. So it looks like the main instance of the application is tied to your individual user, and then that individual user can create these collaboration teams that can have multiple different users accessing that. That's at least what it perceives right now. So currently there's 2 teams under here, and let's see, rename this. There is an option to rename. So let's just go, I want to get rid of this extra stuff here. We'll do demo user 1, team 1, and demo user 1, team 2, right? And by the way, I'm collecting all of these requests in Burp Suite while I'm doing this. So mentally, I'm kind of making notes of like, oh, I'm able to create a team. I'm able to rename this team, which is an update method going to the database. Should it only be me that has the ability to do that? I don't know yet. We got to see what the roles are allowed to do, if there's granular roles within each one of these teams. But I would imagine that I'm the only one that would be allowed to do both of those operations I just did. So those are probably going to be 2 initial attack vectors for both IDORs and access control violations, because it really only should be just me. And that's something you're going to start seeing more and more in this video as we build a cohesive methodology between IDORs and access controls. Is we're looking at, in every instance of a database operation or accessing a mechanism at all, right? We're looking at, does my individual user have the ability to do that? Like, should any other users be able to do it from the individual user perspective, and then also from the roles within the application itself? So we'll see those kind of married more and more. In this case, we have found an instance where only one individual user, I believe, should be able to do both of those operations. So that's going to be an attack vector for both IDORs and access controls. And you'll see that by identifying those attack vectors first, we can dramatically speed up our testing for IDORs and access control violations. So we'll go demo user 1, team 1, and then obviously demo user 1, team 2 is going to be the second one. I would imagine that these are going to have unique identifiers and everything with it. So moving beyond the individual user, we're probably going to have access controls and access to data, right? So if we're testing IDORs, the access for individual data objects, that's probably going to be also controlled at the team level. It could be, it could be very granular across these different boundaries of the application. So that's what I'm trying to figure out right now. Okay, so we've got 2 of those. What I'm going to do, I don't want to walk through, just for extra time on the video, I don't want to walk through a second registration, but I'm going to do the same thing, registering another account, demo user 2, and then we'll be able to test between those 2. So let's smash cut to that. And there we go. So we have 2 user accounts here that are created within the Figma universe, right? We got demo user 1 and demo user 2. Each one of those user accounts has created a team under that user account. So each one has team 1 and team 2. And currently they don't have any users within those teams aside from themselves, but we're going to start to make some connections there too. So we're starting to get this picture of where the boundaries are within this application, or at least I'm starting to put it together in my head. And so one of the things that I like to do when I do this testing is I take my notes here in VS Code, just like I always do and how you've always seen me do it. But I also, to help visualize where these boundaries are and what users have access to what accounts and everything, the other thing I like to use is Xmind. So let's go ahead and get Xmind brought up here too. Xmind is a tool, just a way to visualize your notes a little better. This is something that I usually use both of these at the same time. It's something I haven't demonstrated on my videos before, but really, really great to help you visualize, especially like application architecture and things like that. So I'm just going to come in and select this one. You can use any of these chart layouts that you want to use. This is how I typically like it, and we can delete those here. Okay, and so there you can see we have our central topic. So the way that a mind map works for taking notes is you have this central topic, whatever you're looking at, and then your notes are going to be building off of this central topic. So for us, we're going to use this to visualize what user accounts we have, what individual objects and things are within those user accounts or within the different parts of the application, what's connected to what should have access, should not have access. So that's the reason I think Xmind, especially for IDORs and access controls, can be a very, very valuable tool. So for the central topic, right, what we've done now is we've created 2 different user accounts within this larger Figma application. So I'm just going to call that the Figma universe, like I have been, because that can really encompass anything within the application. That's any subdomain, anything like that, because we don't know how many different applications they have yet. We don't know what their infrastructure looks like. So we're just starting from this one central topic. We know that we have their entire technology stack, everything they have across all their different services is what we're calling the Figma universe. And now what we've done is we've come in and created these two different users. Let's actually do it from this side over here. We've created these two different user accounts. So let's go ahead and pull the Figma universe up here. And within that universe, we've created two different topics, right? So the first one is going to be our demo 1 user, and that is the instance that we created first. And then our second one is obviously going to be our demo user 2. Whoops. There we go. Forgot we just move it like that, make it a little easier. Okay, so we have their larger application space. We have the two instances that we've created, and now we've also created these teams within each one of these demo user environments. So they're kind of tied to each other. So within this, let's create two different subtopics. Whoops, come back over here, and we'll do the same thing down here. And this is going to be demo user 1, team 1. And obviously we'll have team 2 down here. Get that. That's team 2. And finally, demo user 2, team 2. Okay, perfect. So you can see we have the exact same data represented over here that we do over here, but now we have this additional visualization, right? So we can see that these are two separate accounts and they have the teams under their accounts. Now, let's come back over to our application itself. So we still have demo user 1, and demo user 1 here is signed in through the web browser. Or demo user 2, I'm sorry, team 1, demo user 2. So let's get demo user 1 logged in through the desktop application there, and we can take our notes on here as well. So let's come back over here. We're going to hit insert under mind map, and we'll do a label as part of that, and then this one is going to be browser, and we can select this, insert label, and here we're going to have desktop app. And now we can very quickly see this user is going to be operating the desktop application. This user is going to be operating in the browser. And as we go through this, remember, we've added in this additional level of complexity by using the two different types of applications. So as we're testing, we're going to be looking for any unique requests that are coming from demo user 1 that are not coming from demo user 2, because we can possibly target those requests as something that hasn't been tested much by other researchers, or could have unique functionality. Maybe the developers don't expect those endpoints to be targeted because it's coming from a desktop application. There's a lot of reasons that we would want to dial into that there. So let's go back to our notes, and I just want to go ahead and get an extra section going down here. Attack vectors, and then within this, we're going to go unique desktop app requests. Right, and then we can come through and start to identify any of the requests that are coming through for the desktop application that are not required for the browser. And we do already have one of those. If you remember, we come back to the repeater, and when the installation first starts, we have this request that comes through that identifies, the version number, what the release is. It looks like there's a Windows versus a Mac, etc. So we've already got a bit of information there. So we'll copy this, put that request there, and we're just going to sit on this for now, right? We're just starting to put the pieces of the picture together here. So now let's go ahead and start making connections between these two separate instances, right? So we've got user 1, team 2, user 2, team 1, team 2. So I want to have user 1 up here be added into team 1 for demo user 2. So here we come over to team 1. We can open up the team project, or actually, oh, it's right here. Okay, so the project seems to be another layer under the team. it looks like. Anyway, we'll find out here. So, but here we have the ability to invite into the team, and then under that, it looks like we can create individual projects, right? So let's go ahead and hit invite. We could do it by length. Okay, so there's two different ways we can get that. So we could test this logic as well. There could be some way to circumvent this, but we're going to focus on by email. Let's go ahead and come over here too, because we're starting to get, so we're starting to get an idea of the roles as well within this. Okay, so this is demo user 2. So we need to get team 1 added to that. So let's go ahead and send this over. And now we have some different options. So in team 1, we're going to come down here and we will add in this user. And in parentheses, let's see. So, okay, with a link, it looks like we can't set them as an admin. But if we come in and send this to the user directly or the email directly, we can set them as an admin. So I don't think I want to test the boundaries around there, because you can assume, and this would be similar to in part 2, it looks like there's no difference between an admin and the actual user when they create this account for the team. So I don't want to create another user with the same role, because that's not really going to help me. So let's start with a can edit right here, and we'll send that over for demo user 1. So can edit right there. And then let's come over to team 2. Let's send another invite as well. And I will paste their account again. But in this one, they're only going to be able to view, right? This is only going to be read only. So for this, remember, with role-based access control, we're looking to access mechanisms that we should not be able to access. So if they are very explicitly saying, hey, with this role, you can only view projects within the team, you can only perform the read operation within create, read, update, and delete in CRUD, then I can come in to, with demo user 1, in team 2 down here, I can only view it, and I can try to perform any other version of CRUD on any mechanism. And if I can do that, that's going to be a very easy way for me to recognize that I've bypassed the access controls. So let's go ahead and send an invite there as well. We'll come over here. We're just going to copy this. But down here, we can only view. Perfect. And now let's go ahead and we bring my email back here again. So now we have a different email. We've got 2 of them as well, right? Because we just sent 2 here. So now to demo user 1. Yeah, they're the same thing. So 2 of the exact same emails have been sent that says, hey, welcome to Figma. You've been added. You're not going to be able to set everything up, but you can come in and join this instance here. So let's right click on this. Copy link address. And once again, it looks like when we join, the first thing that we do is create a file. So you don't just join, you go in and immediately create a file. So what is a file? Is a file synonymous with project? Probably not, because it looks like there's multiple different things under this team project. So I'm starting to picture now, we have the user instance, and then you can create a team. It looks like the team has projects under that, and then below that there's individual files stored within the project. So could be granular permissions among each of those. I could be just making some assumptions, but we'll have to see here. Anyway, so we right click on this. I think I've already done this, but I'll do it again. And come over. Actually, no, now from here, I'm going to need to do this in an incognito window, a private window over here, because otherwise it's going to share the existing session. So, okay, we've come back over. Now it looks like it's going to have us log in again, which is kind of strange. At wearehackerone.com. Let's just see. Because typically when you click on this link, I guess, so maybe you click on this link, it will take you somewhere and you have to authenticate, because at that point you are, I wonder if it knows that you already have an account, and that's the reason. There's probably some type of logic there to where it says, okay, you enter an email, goes back to the server, and the server said, does a user exist in Figma with this or not? If they do, you come in and we'll have them log in. Otherwise, we'll send it and we'll have them create a new account. I believe that's probably what's happening here. Let's go back to the files. Okay, so here I am, demo user 1. and I have my access to these, right? So demo user 2 teams, demo users 1's teams down here. I do not see my files though. Where did they end up going? All right, so I took a couple minutes here to click around, get a better lay of the land, kind of figure out what's going on. And what I realized is that when that email comes through to your account and you click on that to create a file, what that does is it creates a new file within your drafts section here. So you see here's the untitled file that we had just created, and we can go in and go back out of that, but that's in the drafts. That's not actually contained within any of these teams and then subsequently their team projects that we can click into here. It's only in the draft. So what I did notice as well, and I don't know if you have to do both of them or not, I'm still trying to figure this out, but up here at the top, there's this notification section, and it looks like both of those requests to join the team were sent directly to my user account within the application. So I think I was correct. You've got two different execution flows here when you're inviting a team member based on whether or not they already have an account. If they already have an account, they're going to get an email that allows them to create a file, but that file is only going to be a draft until they take it and actually add it into the team project. And I believe you have to come into the UI here and actually accept before you can do that. I'm not certain, because if you come back over here, team 1, right, we still only see one person. Oh, well, it says 1, but then there's 2 over here. I guess the grayed out is because they haven't accepted. So maybe you can see the invites that are out there, but not, you won't actually see the number or anything until they actually come in here and do it. So let's test that. Let's click on this side here. Once again, still capturing all these requests in burp through the proxy. So we're going to come back and look at all of these here in the future. But I can click on accept that. I will accept this as well. And great. So now we've got the teams down here. But we don't have any access to, well, it looks like there's a project here as well. Maybe these projects are the ones that we control. And that's the reason we can see it listed there. Whereas if we don't own the team, we can only go in and actually access this. Yeah, again, kind of making some guesses there. You can go away. Although that pop-up, I don't know what that was. We can take a look at that. Right, anytime you see a pop-up, anytime you see an iframe, you immediately want to go in and start testing for post messages, which allows for JavaScript to be communicated back and forth, or 2 different JavaScript files really to communicate with each other across separate domains. That's most common with iframes and pop-ups, things like that when you're bringing in a third-party client. So kind of make a mental note of that. We could have some post-message stuff in there, but that's ancillary for what we're doing here. Okay, so now let's bring this over here and let's reopen our xbind file because we built this out a little bit more, right? We've got our demo user 1 over here, but demo user 1 now has access to team 1 and team 2 down there. So let's go ahead and build out a relationship between team 1 there and go from here to team 2 as well. And we can try and make this pretty at some point. In fact, you know what? I don't love that as well. Let's do this. Let's just do some notes instead. We'll insert a note for this, and we will say, oops. Is that copying it? Not the best experience there, probably just because I've got it collapsed. Okay, it is getting the whole thing there. Okay, so for team 1, remember, we want to have this match our other system here. Let's get that brought up, and VS Code. All right, so for team 1, this user should be able to edit, and for team 2, it should only be able to view. Now, of course, we could go and get the same thing set up the other way, but that's not really necessary for what we need to do. So I'm pretty happy with this. Right? Because ultimately what I'm looking for is boundaries. So we have a boundary here, and we have the additional complexity of the desktop app versus the browser. So we can test between these two. We also want to test between these individual teams. So now we have different permissions and things between that. We're going to keep digging in and identifying the additional pieces. So like I mentioned before, we have a team. It looks like there's projects and files that are moving beneath those. So we can start to integrate that. But we don't need to continue replicating, creating all these permissions and everything. exactly between these environments. We only need to recognize a boundary and then see if we can bypass that boundary as well. So that's the next thing we want to start identifying here. Let's come back up. And in addition to attack vectors, because remember, an attack vector is basically a request. It's an HTTP request. There's going to be some type of a location within that HTTP request that you've got user-controlled input that's going to have some type of a negative effect on the application. That's what an attack vector is. The application boundaries, this is what we are bypassing with these attack vectors, right? So we already know there's one boundary here, and that is between the individual users. So, and these are within the instance here. So let's go user to user there. Number two is we've got these boundaries between the roles of the team as well, right? So we've got the can view, can edit, and then we've also got an admin role, which assumedly, or we can assume is going to allow us to go in and modify things like the team name and maybe add other people to the team, etc. So the next two boundaries that we have team view. I like the can view. It just makes a little bit more sense to me. So the team member that can view should not be able to do any of those edits, right? And then for number three, we have team again, but we have can edit. Goes to team admin. Now, obviously, if we can do anything that the view, or do anything as an admin with only a can view, that's going to be the same, that's going to be another boundary. But ultimately, we're just looking to define the clear boundaries here. So I don't want to muddy the waters too much. This is just kind of the way that makes sense to me. And then the last thing we want to look at, right, because remember, we have a completely different methodology here, whether we're doing access control violations or IDORs. So the last thing I want to identify here is, am I going to focus on doing an IDOR? Am I going to focus on doing an access control? Or do I have the opportunity to do both here? So from a user to user, right, we're going to be accessing data from that user object or modifying data from that user object from another user that's probably going to be completely separate from the other one. So this right here is an example of, at least right now, I know I need to do IDOR testing. There could be some role testing in here, but I don't, there's no different roles. These seem to be completely disconnected from each other until we get the user added into a team. So I would be surprised if there were any individual roles that we could, role boundaries that we could bypass through this. Now down here, right, obviously we are looking to get access to mechanisms, not getting access to the data on the user and manipulate it. So this is going to be two examples of role-based access control testing. So I'm going to come over here, RBAC testing there. Now we would still want to try and see if, as a team member that can view, if we can access any data that a team member can edit, right? But we're going to do that through a read mechanism that exists within these teams. So it's going to be role-based access control testing as opposed to unique identifiers. Now, if we do happen to see something that we believe is an IDOR within this boundary, we can certainly test it. But for me, this makes the most sense, right? We have user-to-user testing. We can go ahead and start doing IDORs. We have a couple boundaries within the teams that we can start to test with role-based access control. And we can continue to dig into this. So I know, like I mentioned before, there's the projects that are under the teams. It looks like there's files that are under that as well. So let's continue digging in there. Let's see if we can get a good idea of what the kind of shape of the permissions of these boundaries look like. And then we can start actually sending some requests and doing the test there. So let's go ahead and take our mind map here and we'll move it over to the right-hand side. And now within our demo user 1 instance here, let's come under, so demo user 1, team 1, right? And then we've got this project. So let's just see, can we delete this? We can. Okay, so we can delete, create. I'm guessing we can update. Obviously we can read because it was sitting there. So I do believe I'm correct that within the team you can have multiple different projects. So let's go ahead and do arson 1 for the project here. And there's some additional permissions for each, well, the same permissions. But this looks like it's tied to the project. So invite only. So we have a few different options. It looks like either the project can inherit the role-based access control from the team, or you cannot do either and just set it as an invite only, so only individual users are going to be able to access that. So that's interesting. Let's come back over here first before we actually make this. Those are a couple boundaries that we can go ahead and do. So we have the project, and we essentially have the same, well, just this boundary here. It doesn't look like there's specifically an admin option here, but we do have the boundary of going from can view to can edit, right? Make sure I'm not missing anything. I'm not, yep. So we have this same boundary here. Let's do this. That's the best way to do it. Paste that. Okay. So we have an additional boundary here for users that can view it, that should be able to edit. And then also, let's copy this here, because we do have another boundary that says project invite only. This one should be project as well. And I guess what makes more sense here, let's get rid of this. So what we're accessing is the invite only project, but we don't have any authentication to that, or maybe just say, you know, no invite, right? Because they may be authenticated, but they do not have access to this individual project here. So that's much more granular role-based access control. In fact, it's not really role-based access control. It's discretionary access control based on the individual file itself, but that's a whole different conversation. I don't think we need to muddy the waters that much. So, okay. So let's come back over here to our Xmind as well, and what that looks like from a visualization standpoint, at least in my mind, is we're going to go ahead and create under demo user 1, team 1. We're going to create this arson1 project. Right there. And you know, I kind of want to do this as well. Let's do, because we have these different levels, let's do that. Should have copied the space, would make it easier. There we go. Perfect. Okay. So now we have this arson1 project, and I'm going to come in here and insert a note, and we're going to say that this inherits to where anyone can edit. And that's how we'll create those. So let's go ahead and create that project there. And okay, so now we've got that in here. Over here, we've got the team project for demo user 2. Let's open this up and get that deleted as well. I think we can delete it over here. Delete, that's fine. And we'll add a new project. This one's going to be arson2, just so we can have a different name. And for this one, we are only going to allow, we are not. Okay, so obviously some limitations here we would have to get professional to overcome. So we're not going to be able to test that boundary. I guess we can't set this as only inheriting to view. Can we set it as invite only? We can't as well. Okay, so unfortunately, we're not going to be able to test an additional boundary there unless we were to purchase the professional. Maybe Figma has a way to allow us to do this, but I don't know of it right now. So, but we do have the updated set here. So we have the team level and then we have the project level. So those are a bit of additional complexity that we're adding in there. We can inherit the role-based access control from here, or we can give individual access controls based on the file itself. So we could probably do, or the project itself, sorry, because I think we do have another level, which we should see there, the files. And then we also have these additional boundaries that we've identified. So can we access anything within this project if we have no connection to that team whatsoever? Actually, that's really the way to do it. Let's call that, let's not in team, because that's really it. It's the user is not in the team, but can access the project that is owned by the team when it's invite only. And this would be a boundary no matter what, but again, we're in the same way that can view goes to admin is really covered with this branch here. Being completely unauthenticated and being able to access any of these is another boundary we can test later. So to set expectations for this is just like with everything else we've talked about, this is going to be a constant process. So I'm just picking out the initial boundaries that look interesting to me, or kind of just the ones that are standing out. But this is always going to be a constant process. So these notes are going to be built up more and more and more. We'll dig in, we'll test a couple attack vectors, we'll come back, we'll probably identify additional boundaries throughout our testing, and these notes are just going to build more and more and more. So just like with everything we've shown up until this point, the more time that you spend, the more you dig into this project, you're going to identify more attack vectors, the ones that are tested less and less. And you can hopefully find ones that haven't been tested, and there's actually going to be a valid IDOR access control bypass somewhere in there. But I'm not choosing these for any reason. This is just kind of going through and picking out the boundaries that stand out to me, and simultaneously kind of enumerating what the application looks like. Right, so so like I said, let's come back over again. We've got our project, and then within that project, it looks like we have files. Right, so let's open this here. Go ahead and open this up, and we'll just create a design file. And yeah, it opens up here. Let's just go file arson1 as well. We can name that. And if we go back to the files, we do have that right there. Now if we can right click on this, I don't think there are individual permissions. So maybe every file within the project inherits the permissions that are given to that project. I don't see anything yet that tells me we can do more granular permissions for each file within a project, although that could be the case. So let's just put this here for right now, and we'll do file. And we called this one, I don't remember what I called this one, and it's too small to see. File-arson1. You would think I'd be able to remember that since I typed it 2 seconds ago, but here we are. Camera's on me. I'll lose 20 IQ points. Just happens. Okay, let's bring this back over here now. I don't want to make any notes about this yet because I don't know that this actually inherits those permissions, right? I'm kind of thinking that maybe you can do more granular permissions within a project itself, but maybe I'm wrong. Maybe I'm wrong. So, but now we've got a little bit of a clearer picture. I don't think there's anything below this file, at least not one that I want to start looking at yet. So within the Figma universe, we go in and sign up for an account, and that creates a user role here, a user account. There is a management platform through the GUI that we can go in and manage our user itself, as well as the teams, projects, and files that this user has access to. Below the user, it looks like we can make individual teams, and then we can invite other users within the Figma universe to come in and get access to this team. And there are different granularities between those where everybody within the team can edit the files, everybody within the team can just view the files. So different permissions within that, or at least with the projects. I don't know if that's specifically with the teams, right? But anyway, so within a single team, you're going to have multiple different projects that you can devise, so you've got some granularity there, and then you've got multiple files within that project that you can have, and I don't see much granularity within that at this point. What this tells me, at least to start, because remember with indirect object references, we are trying to access data, which is in the form of objects within the database. And then with role-based access control, we're trying to access mechanisms. So with this, we're starting to get a picture of our objects, right? So let's come back over here as well. We've got our application boundaries, and let's make a little bit more room. And we'll do objects like we had before, and then we'll do mechanisms as well, even though we're not going to start looking at those just yet. So the objects that we have a user object. Still making some assumptions. We haven't even looked at the request yet to confirm this, but based on everything I'm seeing with the application, I think these are fair assumptions. We have the user objects that are created right here. We have the team object. We're going to have a project object, and then we are going to have a file object as well. And then there's going to be different permissions within each one of these. And now individual mechanisms, what we can start looking for are going to facilitate changes within these objects. So, we can start with the user, and most likely we can, well, we've already seen, right? We can modify certain values within there. So these mechanisms are going to be our ability to start finding our IDORs and access controls. Specifically with IDORs, we are going to look for any mechanism that allows us to create, read, or actually probably not create. So read, update, or delete an existing user object, and that will allow us to test this user-to-user boundary, but we need to identify the mechanisms that are going to allow us to do that. So once we have an object that we're going to target, a mechanism we're going to use, an application boundary that we are going to test, those will all go together to form an attack vector. Then we can try to introduce complexity between the desktop application, the mechanism that comes from the desktop application and the one that comes from the web application in the browser to see if there's any differences. But ultimately, that's just going to be to introduce complexity and try to find techniques or a way to bypass this controls that somebody hasn't done. But yeah, so we're starting to get the picture of our unified methodology here, right? So let's go ahead and start finding these mechanisms as well. And like I mentioned, just the easier thing to do, I think, is to come back over here and we can start with our user, right? So we've got demo user 1, and we've got very clearly some mechanisms to modify this. So let's come over here with the user object, and we have change name, we have change email, change job title, change password, enable two-factor auth. Looks like change language. That's a much less impactful one. Right here we have edit on a picture. So yeah, potentially that's going to be the ability, I think, to upload a avatar, right? A picture for your user. So upload avatar. And that's probably fine for now, right? Multiple different mechanisms within that. Maybe if we come down here too, we've already seen a few others, right? So if I can open this up, we've created any of these. We can create all of these. So those are some additional mechanisms that we know we have, right? Let's go and do the team, project, and file, right? So we know we have the ability to create team, create project, and create file. We have done that. Now, we do have the ability to create users as well, obviously, but that is because of let's get our Xbind brought back up here. Because each of these are going to be created within this larger Figma universe, we're not bypassing any access controls. The ability to, or doing the IDORs, we're not bypassing any security controls at all, right? The ability to create these users is open to everybody. So we don't need to identify that create mechanism. Whereas the team, our project, and our file, all of these have to be done from an authenticated perspective. So these create mechanisms are something that we can test because an authenticated user, a user outside of, well, let's say the team, right? A different user should not be able to create a team for this user, right? If I'm demo user 2, I shouldn't be able to create a team for demo user 1. So now we have a boundary that we can test right there. That's our user to user boundary. That would actually be an IDOR as opposed to an access control, because what we would do is it's going to create a team that's tied to that individual user, and it's going to be identifying that individual user by some type of unique token, most likely coming from the session or anything else. So if we can trick that to create a team team project file, anything like that under another user, then that would be an indirect object reference. Now showing impact from that is very different. Remember, updates and deletes, and then sometimes reads. But yeah, those are the main ones we're looking for any of these types of testing. Unless it's like creating something that deals with authentication, right? If you can create an object that's like a session object or a new user object or something like that, then you can potentially bypass the controls that way. So we've got a few different mechanisms here, and if we come back over, so let's right click and what about within our team? So let's start within our team. If I right click, we can rename. So that's going to be an update mechanism. We can delete, we can change the icon. Okay, so I guess we can just write team right here as well. And then change icon. And once again, is this a file upload mechanism? If so, I mean, how much impact does that really have? Now if we come down here, we've got the actual project. So this is the project itself, or the larger project. So we can right click on this. And once again, we've got several different mechanisms. So we can create the project. What do we have? We have add a description. We have move, rename. Right, so update. Probably an update, although this is more of, well, it's definitely an update, but it's updating the link between the project and the team, I believe. Move, I assume, moves it to another team. And then we should have, let's see, we can rename, remove from favorites, that's fine. We can transfer and delete. I don't want to let transfer project and delete. So maybe move project allows us to move between teams we own, and transfer project allows us to send this to another user account, potentially. And if that's the case, can we weaponize this to get access to move a project from someone else's account into ours? Yeah, obviously all of those different tests there. And then the file itself, we do have a lot more options here. So the further down we go, the more options we get. And we'll just grab a couple, right? We get delete. What are the most impactful ones here, right? Open, I mean, maybe if you can read it, but I would honestly just want to, I don't know. I don't know how this works with the open yet. I believe that's going to involve the WebSocket and a lot more complexity than just getting access to a file object here that would have the data. We'll explore create new branch in a bit, but I think the main ones here are share, delete, and move file. Those are the three that I want to focus in on. So because those all involve changing the ownership of this file and potentially allowing me to access these sensitive files that I shouldn't be able to access. So once again, we're going to do share, we're going to do move, and we're going to do delete. All right, so that now gives us an idea of, at least to start, the objects that we're going to focus on, some mechanisms that we can target, and some application boundaries that we are going to try and bypass. Now we've got to figure out the boundaries here once we get more granular with the projects and files, and we can continue to dig into that. But we have what we need to go ahead and start testing, right? I feel very good about this. So I think let's drop this back down. Whoops, how about I click first? That'll make a lot more sense. And we will start focusing on attack vectors to bypass each one of these boundaries. And the first one we can do, because it's fairly simple, we do user to user in an indirect object reference, and let's see if we can manipulate any of these mechanisms to allow us to send a different unique identifier to the server, and the server will trust that unique identifier and perform one of these mechanisms on a user object that we do not own, we do not control. So let's go ahead and get rid of our private browser, because we're not going to need that anymore. Remember, if we go back up to our Xmind, we're going to do our testing for demo user 2 right here through our Firefox browser, and then we want to do our testing for demo user 1 through the desktop application. And once again, we're going to try to find any differences between the way those operations are happening, the way those mechanisms are actually executing, and then we can try and exploit hopefully the ones in the desktop application. We introduce complexity that we can exploit to try and find some actual data leaking or forced data to leak there. So let's come back to our desktop application. We're going to need to log in with our browser again. That will open this up here. Now we just need to get logged in with our demo user 1 right here and do our throwaway password. Log in. And now you can see some of these other throwaway accounts that I've had before, but here's demo user 1, so we'll go ahead and click on that, and we are going to allow this to open back up in our desktop application. And now, also one other thing I want to show, if you come up here, I think we've already talked about this if I remember, but I am going to add this as an attack vector as well because there's some discrepancy here between how you log in with the desktop application and how you log in with the through a web browser, right? So we've already identified one unique request. I want to come down here as well and see, because we just have additional attack vectors, right? When we go, typically it just goes to login, but now we've got the app auth login, we've got our unique identifier, we've got some grant types, so additional complexity that could potentially allow us to bypass some of the authentication that we do. Nothing here for access controls quite yet, although potentially we could access a different application. The question is this tied to an instance within their environment, or is this something local that's just tying it to our application itself? But anyway, save that there. We will get our desktop application pulled up on this side. We can go ahead and close out of this now, and we have our browser-based application on this side. Logged into demo user 2 over here, demo user 1 over here. So at this point, we have everything we need to start testing these boundaries here. So let's come down to the attack vectors. And once again, we want to start with looking at some of these change user mechanisms. And we are testing the user to user boundary, which is going to, we're going to try to do an IDOR on that boundary. So we're going to try to find a unique identifier that will allow us to modify, read, delete, etc., the data of another user that we should not be able to have access to. So we saw earlier, if you come up here to demo user 1, and I'll start from the desktop, we go to settings, and we've got a few of these mechanisms here. Tying them to attack vectors, we just want to see what the actual request is. Remember, an attack vector, we have an HTTP request, and then there's going to be an attack vector within that request, which is the user-controlled data that's being sent to the server. So let's hit change name, and I'm going to bring up Burp Suite on this side too. Down here, over that way, and I want to intercept this request when I send it. Let's go ahead and send this to the repeater there. Maximize this. And so we can see that we have a put request, which a put request will typically be used to either put a new object within the database, or sometimes it's used as an update mechanism as well, as opposed to like the patch or the update, which it looks like that's what this is. And if you look down here in the body, we have a unique identifier, and then we have the name as well. So this looks like a typical, a great opportunity for an indirect object references. Now, this ID itself, it doesn't look like an object ID or a GUID or anything that's procedurally generated. My hope is that essentially what's happening is on the server side, it's grabbing this ID and it's pulling this larger data set here. And let's actually just do test to make sure that this is working, because I'm still intercepted with the proxy. I can actually send this here as well. Send this one more time. And okay, so we have our 200, and we have a much larger user object that's coming through the back end, and we do have the ability to update it. So this is a great attack vector to start with. Right now, it's almost certainly been tested very, very thoroughly by other researchers, and that's fine. We'll still go in and do some basic tests, and as we dig in further and further, eventually we'll hopefully find some of those mechanisms that have not been tested. But let's do this. We have a post request to this endpoint here, and let's start identifying some information about it, right? So first of all, the payload, because this is a, or put, I'm sorry, what am I doing? I would expect it to be a post. That's a little bit more typical. So, and I'm going to do this down here just so we can see what that is. And now we'll go ahead and start with some individual things. So this mechanism is to update user name. The aspect of CRUD that we're doing here is we are doing an update, and that is being performed on the user object. I don't want to add that in there as well, right? The object is going to be the user. We are attempting to do, or the boundary that we're attempting to bypass is boundary user to user, and then we'll write IDOR right there. And then because it's an IDOR, what we need to find now is the unique identifier that is being used to identify who owns this object. Now, my hope is that it's going to be this ID here. Just add a little question mark there saying we don't know. That's the best case scenario. The best case scenario is that, actually the best case scenario is not only that this ID value is being used to identify the user, but also that every time you create a new user, it just goes up by 1. So we're currently on this many users, and it's going to go 4, 5, 6. So it's going to be easier to guess those individual numbers. That's probably not the case. These are all these ideal scenarios, right? So I start by explaining an ideal scenario that you've probably seen in like a capture the flag or, hack the box, try hack me, all those different ones there. And then we bring it up to like, okay, but what does it really look like in a real world application? Because no public programs on HackerOne are going to have that very traditional thing where you're going to see it. So you got to be able to identify what it looks like in a real application. This is I'd be very lucky if this was really what was happening, where it was just identifying that and then going in and validating that the user actually owned it, probably through the session. Who knows? But that's probably not the case. First of all, are these sequential? We don't know yet. So that's a question we've got to answer. So we got our questions, right? I don't need to write questions, but that's what these are. These are going to be questions. So are the ID numbers sequential? I want to answer that. Question mark there. Is the ID value used to pull the larger user object? I don't know about that as well. And how does session come into play? All right. So let's go ahead and work on answering these questions. And the first one's pretty simple, right? Are these IDs sequential? Well, we already have one ID value here. So for demo user 1, we have this ID here. And I also want to start documenting this because we're starting to get a little bit more information. So ID, we have that. And then let's get the ID for team 2 or demo user 2. And the other thing we're going to do at the same time is we're now going to send the same request through the web browser. And we're going to see, is there any difference? I mentioned in the beginning, are they using the same API endpoints for the desktop browser and the web browser? I think for this, they probably are, because it doesn't look like there's a lot of difference between the two. But maybe not. Is it still going to this API? Where is it? API user? Or have they created something completely different for the web application and the desktop application only leverages this API itself? That's what we can find out. So we'll close out of that for right now. Let's get our browser brought back up here. We did not need that to open as well, but thank you, Windows, for trying to make some assumptions. And we'll come down here to our demo user settings just like we did before. And let's do make sure that we know what these are as well, right? So this is desktop install initial request, and then we have update name demo user 1. And now we'll grab the one for demo user 2. So just like we did before, change name, demo user 4 test. We will intercept, we will save this, and we have our answer. So in this case, both the web browser and the desktop application are leveraging the same put API user endpoint. And we don't have any changes between this as well. So this request, we'll send it over to repeater. Maybe there's some differences in the cookies. Obviously the user agent is going to be different, but that's probably going to be about it. Let's turn this off here. We'll go ahead and let that go through. Go to repeater. And now we're going to have update name demo user 2. And if I come down here and just rename them to demo user, send that. And we see everything looks basically the same. Demo user 1 right there and demo user 2. Now the IDs, that's what we're initially looking for. Our demo user 1 ends in 713 and our demo user 2 ends in 622. So just at glancing, it doesn't look like it, but who knows. So we have, at least for the first ones, some similarities. but they're not sequential, almost definitely not sequential. There's no way that between the time we made the first and the second account, I mean, I don't even know what that number is, but essentially billions, if not more, of accounts were created. That did not happen. So these are not sequential, but they're not really too difficult. I mean, it's a little difficult to guess, but it's not as difficult to guess as like a GUID or even an object ID or anything, right? We only have numbers to guess here. We don't have hex values. We don't have any dashes or anything to worry about. So this is not the greatest opportunity for an indirect object reference, but it's not a terrible one as well. So we have our answer to this. No, only digits, some pattern, and we starts with 133. I'll just put that there. I think that's fine, right? They're not sequential, but there's only digits and there's some pattern. It is easy enough, I think, to guess, and we don't know if we can exfiltrate it as well, but at least to be able to guess. I would say that if we find a valid IDOR, it's probably not out of the question to say that we could guess other random users, especially considering how many different users there could be. So I don't have any problem showing impact through brute forcing with this just because there's only digits. Once you get up to hex values and the longer it gets, it can be really, really difficult to try and make the argument that you can guess that ID value. But okay, so we at least know if they're sequential, right? And if you see my other videos, especially the client side injections video, this probably makes more sense. But a lot of what I'm doing when I find these attack vectors is I start to probe a little bit to see if it's worth my time. So that's what I'm doing right now. Is this worth my time? Well, the IDs are a bit sequential. This is not the most secure way if they are using this ID. So there's enough information here from answering that question that I can move on. And it's worth my time to answer the next question, right? Is the ID value the one that's actually being used to pull the larger user object? Now that can be kind of difficult to really identify. One thing that we can do, because there's really only two options, right? Well, three, I guess. Something coming from a header, which now that I say that, we've got this X Figma user ID and a value there. So that may be something that's identifying as. I'd be really surprised if they were identifying the user from a header, but it's not out of the question at all. Maybe this is more of like a validation. But then it also could be coming from the cookies and most likely from the session here. So let's get rid of any of these cookies that we don't need and go ahead and move these out of the way first. I don't think we need the recent user data. And then we've got a lot of these Figma dot. So Figma.session, session, Figma.mst, let's get rid of that. The rest of these here, I don't know. Typically if you, these especially we can get, or this one right here, we can especially get rid of. Typically if you have a single underscore, it's a tracking cookie. I don't know what the difference is between these underscore host Figma and the other ones. This is just Figma session, but it's possible that the cookies are different. Well, even based on the request, do they both have those? They both have all these same ones. I don't know what the difference is between those hosts there, but let's see, is it just the session token? Let's first of all send this again, make sure everything's okay. We're still getting to 200. So let's get rid of everything but the session token. And now we're unauthorized. 401, so that is literally unauthorized. That's not, 401 and 403 can be very similar. It's not saying, I don't know. What are the other ones up here? That could be saying a lot of stuff. I don't know what this DID is. I'll tell you what, let's just start getting rid of these one by one. So we got rid of the DID. We still have a 200. This one's auth in and then actually has some data that's looked like it's stored in there. Let's come up here and do this. Let's get a pointer section up as well. I'm just going to grab this cookie because it's named auth in and there's data that's stored within it. And then let's see if we get rid of it. Is that having any? It is. That's giving us our 401. Okay. So we need to have that. So are they identifying the user through this somehow? Because this has data that's stored within here. Let's go ahead and copy this and send it over to the decoder. Smart decode. And this value, I believe, matches our user ID as well. So we have a user ID here. We have a user ID in the cookie. This is really interesting. And then we have this like dot notation. So looks like a random sequence of strings. This very clearly says auth in. And then we have another value that looks similar to a few other things that I've seen here, but it's not a standardized. It's not like an MD5 sum or a hex value or anything like that. But there's multiple different ways that we can do this. So, okay, let's actually, I'll move this off of this here. And we can come back over here. I'll tell you what, let's just grab this, and then let's also grab the header. Right. So I see 3 different areas in this request, at least just in this, to where they are identifying the individual user. We know this auth in needs to be there. Let's try, what about this one too? Maybe it says auth in state is 1. Maybe that's true. Oops, sorry. Go forward, Control Z, there we go. Figma auth in state equals 1, so maybe the 1 is true, and if we send a 0, it's false, and it would just kick us back. I don't care if anything's there, just out of curiosity. Let's just go forward. That's fine. Okay, so we need that. Where did our other cookie go? We lost our other cookie. That's fine. Get rid of this here. Replace it with the one we know we need. Make sure that's still working. Gives our 200. So we don't need that other cookie at all. Let's see. Can we just get rid of the rest of them? Maybe it's just the session and the auth in. That looks fine. Do we need the session? You got to assume we need the session. We don't need the session. Really? Interesting. So this is all we need. Can we do the same thing on the other one? Is there maybe, because demo user 1 is coming from the desktop, maybe we need the session for the web browser and the auth in for the other one. Here's the auth in one too. This would certainly make it much easier to test. That's a 200 as well. That's totally fine. Okay, so the only thing that we need, let's come back over here. We don't need any other session tokens. This is what a full request will look like towards this attack vector. And then we've got, basically, come over here and copy this, put it down here, we can see immediately. It's in the referrer as well. So maybe, well, let's add that as well. I wouldn't, certainly this is not going to be the main way that they're identifying it, but perhaps all of these are used together in some way to validate it. You know, maybe this whole system breaks if we, maybe we change this value and then it says, well, let's validate it with this, and then let's also validate it in the referrer header. Let's also validate it in a cookie. So that would be really interesting if they had multiple, and this is kind of the compensating controls for an IDOR, right? Is you've got to, you can just accept that this ID value is okay. And, you know, at that point, you're trusting user-controlled input. That's never a good idea. So even though these are all user-controlled input, this could potentially be what the developers thought. Well, the users are not going to be controllable, and then the referrer is really hard to control as well, and then we've got a cookie. So if we just validate that all 4 of these match, then that will be perfectly acceptable. We're going to know that it's the right user, and we can go ahead and perform, basically serve the data back or change the data for that object. We can trust that the user controls or the user is who they claim to be, as long as all 4 of these match. I don't know if that's the case. We will see. So, yeah, and again, we don't even know if the ID value is the one that's pulling it, although I guess it would have to be, unless it's here. Unless there's some type of a session token hit here, and this user ID doesn't have anything to do with it. So the answer to this is it can only be one of 2 things. They can only do it, yes, unless they use the unique token at, and then let's just grab the right here. And we'll add some single quotes around that, make it look a little nicer. Perfect. That's the only option, because this request goes to the server and it changes it. Either they are using one of these ID values, to identify. I guess they could use the name as well, but that's the name that's being changed. That doesn't make any sense. This can be whatever test is changing over here. So no, there's no way they can use that. So they're either using these values here. Very close. Maybe this is a team value here too. But anyway, sorry, got distracted. They're either using one of these values here, or they are using the value of this key value pair in here, and maybe there's some type of combination of that. Maybe they check this and then validate it with a key and then go in there and test that, etc. But that's the only two it could be. That's the only two it could be if this works. And then how does session come into play? Well, not at all. Cookie isn't needed unless this value here so hard to do that, is the session token, right? So unless this value right here is the session token, then the session doesn't even look like it's validating the session. So that's another pointer that maybe I'll do. In fact, let's just kind of modify this here. Is only cookie needed to validate, or to, let's just say, change user object. That'll work right there. Okay, so we've started to dig in a little more. We have identified an attack vector, right? It is going in to modify the user name. So the only thing left to do is to test and see if we can change user 2 or demo user 2's name with a request coming from demo user 1, and then vice versa. So we can go ahead and start testing that now. So let's come back up to the top here, and we've got, right now we're sending the request to change demo user 2's name. So we're just going to grab user 1's ID here, and let's start by just changing it here. Let's see. So what we know is that we have a combination of ID values within this. So I guess we just got to figure out which one is being validated, which one is not. So we'll start by just changing ID and send this, and we still get a 200. Okay, so what's the best way to do this? Let's just do test. And then what do we have? We have cookie, we have refer, that's not how you spell it. We have x/Figma, user ID. Let's just call it xFigma to make it easier. And then we also have our ID value down there. And then I'll just do KVP. I just want to make them look all a bit even there. That's the way that makes sense. All right. So we have our first test right here. And this one is going to be user 1. This is user 2, and user 2. Again, whatever makes sense for you. I'm just kind of making this up as I'm going along too. Everything is different, right? Every application is different, but this is what makes sense to me, right? So we're going to do this test here, and I'll actually change this. You call it whatever you want, you know. But ultimately, we want to see what happens as a result to start getting ideas. So when we do user 1, user 2, and user 2 with this combination, what do we get? Let's come over here and do test. So does it work? It does still work. Okay, so we'll do works and changes user 2, right? We still see our user 2 object up here. So changes user 2. Let's call them demo user 2 right there, just like the other ones. Okay, so let's keep repeating these tests here. So in this case, we are not seeing any effect. I'm just going to keep walking these up one by one. Let's see what happens if we also modify this here in the Figma user ID. Now we're unauthorized. So if we do user 1, user 1, user 2, user 2, we get unauthorized 401 response. And no message or anything else, it just says that. So test 2 does not work at all. So let's see if we can unbreak it without having to modify any of the ones we've already modified. So test number 3, we'll see what it does. I don't think the referrer is going to have much of an impact there. Let's try this one. Let's see if we can modify this. And the great thing about this cookie, anytime you see a cookie that's storing data, the first question you should ask yourself is it validating the integrity of that data? Based on this, we don't think it is. What I mean by that is it somehow signed to where you can't come and modify this information? Typically, it's going to be like with the JSON web token. You know, you've got the header, then you've got the payload, and then you've got a signature that's used to validate it. Usually when you have any type of a cookie, especially something that's a session token that stores data, then you would want to have some type of integrity check to make sure that this has not been modified by the user. And that integrity check is just going to take some part of the information within this cookie, specifically probably this data storing thing that can be changed, and then sign that with some unique code that's stored on the server side that we would never have access to. So the idea is that if I come in here and I modify this to be this new user value, is there any way for the server to know that I've modified this? So if this had like a dot, blah, 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 like that, then I would probably say, okay, this has been, you know, signed by some type of a secret or anything. But we don't see that here. It's just a raw data store. Now, what could be happening is they are signing this user ID with something in the back end and just appending this as the value of it. And then that's what this is actually a signature as opposed to a session token or anything else. We don't know, but just glancing at it, it doesn't look like it has any integrity built in. Integrity just meaning that when the server receives the request, it's confident that it has not been modified by any malicious attacker. And obviously we are modifying it because we've captured it in our proxy here. So let's send this now with the updated auth-in token. And once again, we still get an unauthorized. So when we do user 111, we get the same thing, unauthorized 401. So let's do our final test. Well, not our final test, but I think we have that right there. No, I don't. At least the final main one here, right? So test 4, and let's just see if by some chance the fact that this referrer ID is causing that, and it's not, right? Okay, and I just kind of left it there because I would expect. So based on these tests, it looks like either some combination of the ID and this header are used to identify the user, but this value here has to come into play somehow. It's either signing the integrity of this cookie or this value, or it's a session token. I'm not sure. I'm thinking more of a session token than anything else, but it doesn't seem to have any impact on, there doesn't seem to be a way that we can modify these, at least initially, to where we can get it to accept that. Now, the one thing that we have not tried, and we can go back here to our first request, we'll do demo user 1 test, is let's just see if we can get this demo user 1 identifier with this ID. And maybe that's it. Maybe if we just change this is the last test I want to run on this one here. And once again, we have a 401. So this header is definitely important. It seems like modifying just that header causes the functionality to break, right? And we can try different combinations of this. We could come up here and let's just see if these two and the other ID works, but I really wouldn't expect that. Yeah, all of these are still unauthorized. So we'll come back here and do one more, copy. And what do we have? 2, 2, and 1. All right, so the results of this test tell me that the Figma user ID header is important for validating requests to modify the user object. So we'll start to kind of take some different notes in there. Yeah. So I don't know exactly how this is being changed. I'm fairly confident that what's happening here. If we can go back to where they're all for, I'm fairly confident that what is happening. Good grief, I can't talk now. Is that the server is receiving this request, and the first thing it's doing is taking this value from the header and validating it somehow with the session. I think it's probably taking this, going into the session. I think this is an actual session token here. So I think it goes in and finds the user ID. It probably goes through here, and the reason it has this, it may be looking for multiple key value pairs within this. So that's something that we could potentially test. But I think it's going in, it's validating that this is the session token, and then from there, it'll go back and say, okay, grab this ID, go back in and make the modification as well. So based on everything that we've seen here, I don't feel like it's a good use of my time to continue testing this attack vector. We have a lot of different ways that we can continue to test. I haven't seen anything that tells me that there's any variation between the desktop application and the browser. So I think we can kind of move on from there. Let's try one more test on the user-to-user boundary here, just another one of the changes. So let's send this down here, and yeah, let's go ahead and just do something easy, right? Because the email here is going to be a little bit more complicated. Let's just see if this is handled in the same way. Let's just try the job title. Actually, sorry, let's bring this back up. Proxy, intercept, change job title. I'm going to do user research now. We can send that. And yeah, so anybody who watched let's send this to Peter. Anybody who watched my live stream looking through Figma we did mostly server-side injections, talk a little bit about client-side as well. But if you watch that stream, you will already know this. But the Figma application actually has a misconfiguration called mass assignment on API. It's one of the higher items on the OWASP API top 10, and that's mass assignment, right? Like I said, what that means is that if you look at the actual route, the attack vector, if we come over here and copy this next attack vector, it's the exact same thing. The only difference that we see here, by the way, I need to bring this down here because that's not what I was really looking for. Just realized I accidentally did this. Cut this out here because this is the body, and then we have the additional ways to potentially do it there. So let's copy this. But here instead, we have a completely different request body. We're still sending the ID, but we no longer have the name. Instead, we have the job title, we have the profile, we have this additional information in here. What does that mean as far as our testing? Well, mass assignment means that they have built one endpoint to do multiple different operations based on the parameters that are included. So there has to be some type of a try-catch on the back end here that's saying, well, if the request has ID and job title and et cetera, then we wanted to do this one operation. We wanted to update this job title or whatever it was value there within the user object. Whereas if it has the ID and the name, then we wanted to update the name. So I dig into this a lot in my most recent live stream. If you haven't seen that, I'll put a link in the description. You can go down there and see me do a deep dive into this mass assignment endpoint. But ultimately what we would be looking for here is, and the reason this is not a good idea at all from a developer security perspective, is that there's a lot of complexity that goes into that where if it has certain key value pairs but not having other key value pairs, you can cause unexpected behaviors to happen, right? And a good example is with this here. So we know it's looking for the ID and the name, and it will change the user's name. What happens if we include the name as part of this? You know? Oops, what am I doing? Right? And we'll just call it test right there. How is the server going to handle that? Is it, when the code is actually written, is it if else to where it's only going to change one? Is it multiple different if statements, so it's going to go through and change all of them one by one? If so, what's the priority? What changes as it goes through? Is there anything that changes within running memory as it goes through those different try catches? Anytime you're adding complexity into this, where you're forcing the application to do those determinations based on like what parameters are included or anything, then you can force the application to act in a way it's not intended to. And that's always what we're looking for as the first step to finding a bug. So let's send this and just see what happens. Did we still get a 200? Took a little longer than I expected it to. We still have a 200. We did update our name over here. Thought that was the same thing. Maybe those are the same thing. Maybe name and handle are both updated. Did we update our job title? We updated that as well. Yeah. So is this the exact same endpoint? I mean, is this, is it just doing all of them at the same time? We know it's the exact same endpoint. Is it just doing both of the operations at the same time, one by one? Is it taking the entire user object and going in and just adding that into the database automatically, like changing any values that are in there? Are we able to change additional values? Can we go into this, like we have this OAuth tokens and these dev tokens values. Can we potentially add this as a key value pair and inject an OAuth token into there so we can possibly get access? Anyway, that's outside of IDORs and access controls, although we can potentially inject values into this user object that would allow us to get an IDOR or bypass access controls in the future, right? Do we have any roles? You know, maybe we have things that access certain projects, etc. But I don't see that here. So anyway, because this is an endpoint with mass assignment, it's a fantastic attack vector for server-side request, or not server, well, yeah, any server-side injection. So server-side request forgery, any type of server-side injections. But this is not going to help us much for IDORs and access controls because we've got all the same validations for the permissions that are going here. So everything that we just ran into for this user mechanism to update the name, we're going to run into the same security controls for the user mechanism to update their job title, right? So that's an example of how we can do some basic IDOR testing in here. I want to move away from the user to user boundary that we're testing. Where are we back here? And I want to look instead at testing the boundaries between the teams that we had, right? We had these different ones here, and now we're starting to do the role-based access control testing as part of that. So let's move back over here. And just like last time, we're going to start with our desktop application first to see if there's any variability between sending the request through, or performing the action, I guess a better way to say that, between the desktop application and the instance of the application that's loaded within the web browser. So we're back over here to demo user 1 and looking at the teams here. So we've got the demo user 1 teams that we control. And if we right click, we can see a lot of these different things over here, right? We can copy, rename, all the mechanisms that we've identified. However, if we come up and look at our demo user 2, which are the teams that we were invited to, we can right click on this and see, well, we can only copy link or leave the team for that one. Now that one's for team 2. In team 1, that looks like we only have those same options too. So obviously that's a boundary, right? We have identified areas where, at least based on the client side, they do not want us to perform these actions there. So let's see what we can do within our team. And I don't want to delete it yet, even though that's going to be one of the more impactful mechanisms. I'm going to start with the mechanisms that are, I don't really care about the impact right now. I'm just trying to get an idea of what the validation patterns are. And in fact, that's something we're going to document in our notes very shortly here. So let's find some way to test this mechanism where it's not going to start deleting things or really modifying it in a way that's difficult to replicate. So we'll just start with a rename operation here, and we'll just come in demo 2 test. It's as simple as that. And in Burp Suite, we should see in our proxy that we had that executed somewhere within here. Now, it looks like the request itself is fairly complicated when I'm just pulling this up. Ah, here we go. Okay, so we have a put request. Yeah, that should be the most recent one here. So let's send that to the repeater. Make it so this makes a little more sense. And we'll send that. And all we're sending is this name here. So no more ID, right? At least not a user ID. Now we are most likely changing this. This is probably the ID for the team itself. But there's only a name that is going to be changed within this here. And just to make sure, right, because there's our test, let's get it to come out again. And we do see that that's changed there. Perfect. So we can come back over this way and get rid of the inspector for right now. I'm going to copy this URL, and this put request to this endpoint. And we're seeing a similar pattern here again, API teams, API user right there. That makes me think that we're not going to see any change between the request coming through the desktop application and the one through the browser, but we can find that out very quickly here in a second. So let's move this off here. Oh, that way. And we'll get our web browser. Oh, that's our desktop. Get our web browser brought up. Yeah, they look the same there. And let's do the same thing. So now we've got demo user 2. Right click over here and we're going to rename this to test. If we come to the proxy, we should see, yep, put API teams and the parameter ID there. So it looks like we have the same thing. We can send this again. We should see the test right there. And it looks like it doesn't even check to see if anything's being modified, because you notice we're still getting 200. There's no errors or anything. I guess that's fine. Makes me think that maybe they're just taking this value and just throwing it in there. And I'm thinking there's less server-side validation than there really should be, but maybe that's what they want me to think. I don't know that for sure. But we did see this move over here. So let's come over and we're doing update team name. And this one is demo user 1. And then we'll set this as the same thing here. And I forget what this one was. Oh, right. Okay, so we can just move this off because that was just part of a separate test, although it is something that we would, it's an attack vector and probably something that we would end up testing. But based on the mass assignment that we've identified, I think that ultimately this is really just one attack vector. And what we need to do is go through this very large user object here and one by one find out which one of these key value pairs we can modify with a put request and which one we cannot. But that's more for server-side injection testing. If you go back and watch my live stream, we go through that for a little while, but not in scope for this pre-recorded video that is already 2 hours, which is longer than I wanted it to be. So let's come back over here to our notes. And we're going to do the same type of thing again. Oops, did I not copy it? Try this one more time. Copy. There we go. So the mechanism is to update team name, right? Form of CRUD, object being modified, value being modified. That's what I typically try to do. So once again, CRUD update object is now going to be a team object, and then the boundary that we are testing is, and it's really trying to do anything other than an admin. So the boundary itself here is going to encompass basically both of these at the same time. So let's just do team non-admin to team admin. And then we have to do, this is a role-based access control test as well. Let's do this just to make it a little easier. I like that better, right? So any team member that is not an admin, so if they're set as team can view or team edit, honestly, if they're unauthenticated as well, that's something that we would test. But ultimately, this is the boundary. So we need to make sure that only admins have the ability to update, to perform the update mechanism on a team name here. Right? So we can very easily test that, right, by just adding a non-admin user to this team here and using an admin user to send a request that's going to update the team name, but we'll capture that request in burp and we will replace, we come back over here and get to the right request, we can replace most likely just the cookie and this user ID in the header. Possibly the referrer has some impact, and I would kind of want to test that, but we know for a fact that at least these two make a difference there. So again, very easy test to do, role-based access control test, but before we move in and actually do that test, I want to call out one of the things that maybe you've already recognized, which is we've identified this one boundary that we have, the role-based access control boundary, but we've got another boundary here that's actually going to be verified or validated before we reach this role-based access control boundary, and that's actually an indirect object reference boundary, right? that's coming from the ID up here. So this ID is related to the team. And let's actually bring our Xmind back up, because this is where it can really be helpful. So we are checking to see if a non-admin user that we have created, so these are our admin users, and we are creating additional users to add into these teams that are outside of these two. Now we are checking to see if the user that exists within this team has the permissions, has the sufficient roles to access the mechanism to update the name. But the first check that's going to be made is actually an indirect object reference check. The first check is going to be on this ID in the path parameter here, which is associated to the team. What the application is going to do is it's going to receive this request. It's going to take this ID of the team outside of this path parameter. It's going to say, okay, this user is trying to access and do something within this team. So before we do anything, we need to make sure that this user, this client, has the ability to interact with this team whatsoever. Do they have the ability to use this unique identifier to access the larger data set of the team and ultimately modify that data, read that data in some way? Can we even access this team object over here in the first place, right? So once that's done, so in this case, we're added to the team already. We do have those permissions, so it's going to pass that initial check. It's going to move on from that boundary, and then the application is going to test the roles. It's going to say, okay, this user has access to this team. We're fine with that. But now we need to check and see, does this user's role have the ability to perform this specific mechanism, which is the update mechanism on the team? Well, let's go back and take a look. Well, only admins are supposed to be able to perform this mechanism. We know that this client, this user, can access the team. That's totally fine. But now they want to come in and start modifying the team name, and we know that only admins should be able to do that. Well, let's grab this value here. Let's take the session token. Let's make a query into the database and say, hey, who owns this session token? And by the way, just do an additional check in here to make sure that this value in the header matches the value that comes back. Let's just add that additional layer of validation, right, as an additional compensating control. But the application asks the database, who owns this session token? It comes back and it says, well, this user owns it, and yeah, it matches that header, so we're okay there. And the application goes, okay, good. So everything's good so far. They want to change the team name. Is that okay? And then the database goes, well, they only have can view or can edit permissions. They're not an admin, and I think you know that only admins can update. The application goes, yeah, only admins can update. So never mind, we're not going to let them do it, and we're going to get denied right there. That is much more indicative of IDOR testing and role-based access control testing within a web application. Typically, a single request is going to test the boundaries of IDORs and role-based access control at the same time. And so that's why it's so important to have a unified methodology. Most requests, you're going to look, and the first thing it's going to do is validate, does your user have the ability to access this data whatsoever? And then if that validation passes, then it'll say, okay, now if there's role-based access control, let's go in and take a look at the roles here. So we need to do the same thing with this request. We need to come in and say, we've got our boundary here that we're going to test for the role-based access control, but we need to have an additional boundary that we can test first, and this is going to be just any user. Oops. Do they have the ability to access a specific team? It's as simple as that. Does this user ID have the ability to access the data that is pulled back when this team ID's identifier is sent to the database? So we can test first of all to see if we can get access to team objects through this request that we should not have access to. And then once that testing is done, we'll come down here and test the role-based access control and see if we can make this update mechanism when we shouldn't have the permissions to leverage this update mechanism. Now, in order to do that testing, we're going to need the object ID or whatever this unique identifier is that relates to each of the teams so that we can try and access a team object that we should not have access to. So we need to go back to our notes. Let's go ahead and copy this. And go ahead and document the unique identifier for each of these teams. And then here shortly, we'll probably do the same for, I think there were the projects and files and, you know, whatever the other objects that are in the application. So this ID here, we already know is for demo user 1, team 2. So we can go ahead and get that documented up here. Let's go ahead and click on the right one. Maybe that's a good idea. ID right there. Now let's go ahead and get this copied out because we'll do the same thing for the other teams. There we go. And then I want to do the same thing in Xmind because, again, this really makes it easier to visualize, especially when we're doing this type of testing. So let's come over here to demo user 1, team 2. We'll hit a note and same thing. ID, put that right there. That way we know exactly where they are. Now to find the other ones, I mean, there's a few different ways that we can do it. Probably the easiest way, because we have a pretty simple put request here that we've set for a few of them, but we know that any operation with the team seems to contain that ID in the path parameter. So we can come here up here to burp search, and I'm just going to search for the path, right? API/teams right there. And we'll do only the request headers and only requests that are coming through the proxy. I just want to see natural traffic as part of exploring the application. We don't need to see anything from the scanners there. And we should pretty quickly see at least a few different kinds. Now the challenging part doing it this way is figuring out which of these teams is, or which of these IDs is tied to which team, right? So hopefully something within the request itself. There you go. So this one right here, this ID we can capture, and we can see that this goes to demo user 1, team 1. So let's go ahead and insert that right here. Perfect, perfect. And we want to get that added to our, come on, go over there. We want to get that added to our VS Code as well. And let's just make sure that these match, right? Because this can be a little bit tedious and easy to make mistakes, right? So the final one's 5785, 5785. That looks good. Over here, 6582, 6582. Okay, so I feel pretty good about that. So these are for our demo user 1. And let's come back over here and see if we can find our demo user 2. There we go. Demo user 2, team 2 is going to be right there, right? I didn't read that wrong. Yep, I'm correct. Demo user 2, team 2. Let's go ahead and get that added in over here. And we should be, or should see one more unique identifier. I think this is it right here. Maybe, do we have a put request or anything? See, this is where it gets a little bit more complicated. So tell you what, let's go back and do it the other way. Let's go back and do it the other way. Let's close out of this. The only one that we don't have right now is demo user 2, team 1. So just so that I can demonstrate this as well, here we have the team. Another easy way to do it is just to right click, and right, we can just rename it. We can perform this operation there, and we know that in our proxy, we will see a put request. Send this to the repeater just so that we can easily grab it. And we know that this ID is going to match that there. So that's, again, you can use search, you can go in and do the mechanisms manually, totally up to you. I just kind of see what I'm feeling that day, so. There we go. Now let's get this added. Whoops. Come back to me. There we go. Let's get this added to our VS Code notes as well. And once again, let's just make sure that everything matches. Team 2, 2279, 2279. Team 1, 8410, 8410. Perfect, perfect, perfect. And none of these match. I haven't duplicated. Okay, so that's good. So we've got our IDs. Now we can come back over here. We don't need to keep that. And we can begin our testing. Now again, we're going to start with the IDOR boundary testing. in which case we just need to have a request coming from a user that does not have any access to this team. And we're going to find out if we can get access to teams that we shouldn't have access to, get access to that data there through this attack vector in the path parameter, which is a team ID. So we can very simply just come over, we'll copy these IDs into that and see if we can get a valid response like we did before. If we can actually access that data in any way, that would be an indirect object reference, and we can go and submit that. Not expecting that to happen, right? Just to set expectations, 99.9% of your tests for this are not going to work, right? It's, remember, we just have to find one, and that can be a very, very significant bug. So even though this is not highly complex testing, it's much more about methodology, about understanding the application. Remember that it just takes one time for these operations to be successful when we expect it to fail to actually have a very impactful bug, depending on what the mechanism or what the data we're actually accessing is. So we'll test that IDOR boundary first, and then once that is complete, we will then go and test our second boundary, which would be the role-based access control. So two completely different tests through this one request, two different attack vectors through this one request. So let's start by testing the IDORs. And instead of just running in and doing our tests like we have before, let's plan out our tests a little bit here. So I'm going to come in here, bring this out, and we'll do tests, right? And then we're going to do multiple ones under that. Now, we don't really have any questions for this one because this is very simple, right? An HTTP request is going to the web application. It is checking to see whether or not our user has the ability to access this team object. That's it. Very, very simple process. Everything we've already answered about the user ID, etc. in the last request, though everything is still going to apply, we believe. If we see any differences in functionality, then we'll note that, but I'm not expecting it. So let's get our Xmind back up here, because again, it's a little bit easier to visualize. Bring this up. That should be fine there. Okay, so we have 2 different users and 4 different teams. So we're going to conduct 4 different tests, essentially. We want to check and see. We could really do 8, right? But I don't think that's a good use of our time. I think we can check everything that we need. We can have this user check one team that we know they have access to, one team they don't have access to, and then vice versa. Now, we have added team 1 into our team 2, into these demo users teams. So we would expect that this user can successfully access a team under both users. And we would expect that this demo user will not be able to access and modify any data from these teams. So we're going to do 4 different tests. Like I said, test 1 is going to be demo user 1, seeing if they can access demo user 1, team 1, right? So can they access a team that they own, right? And our expectation here is that it's going to be successful, right? Because this user is an admin for this team, right? They own this team, they created this team. There's no reason that they shouldn't be able to access that. So let's copy this over and let's get our other 4. And now we'll do demo user 1 again, but now we're going to do demo user 1 to demo user 2, team 1, team that they are added to, right? And once again, we would expect to see a success, right? Because this team has been added in here. We're just checking to see if they can access this team whatsoever. Now, the put request that we're going to be submitting to do this IDOR testing, this would not be successful because there's a role-based access control test as well. So we would probably, if we really want to thoroughly test this for an IDOR, we probably have to check somewhere else to see if we can access that team at all. Which actually, yeah. So with that additional layer of validation, I think that's the way I'm going to handle this, because we can go and find additional attack vectors, but at least for the sake of the video, we'll just stick to this one. So with that being said, we would expect this to be a fail, but because due to our BAC test. And what we can do with that is we can check and see what the error coming back is. Now, if the errors are the same, whether the RBAC boundary or the user to team boundary is the one that's failing, if they're the same response, then we might not be able to tell. But I do believe it'll be successful for this first boundary but fail on the second one, do the role-based access control test. Now the second one over here we're going to do, or the last ones, we'll do for team and demo user 2. So now we'll have demo user 2 access a team that they own. Demo user 2, team 1. We should obviously expect that to be the same as well. And then finally, we are going to try to have demo user 2 access demo user 2, team 1, which they should have no access at all. So we expect this one to fail, but this is going to fail due to IDOR test. And we will compare the responses between these